In this video, we are going to continue our work with graphing cotangent, tangent, cosecant, and secant, and we are going to look at some vertical shifting, as well as some amplitude changes and period changes as well. So we're going to focus on the letters A, B, and D in this book, which you might also see as alpha, omega, and beta. All right, so start off with a cotangent graph. So let's get going on that. The cotangent graph, I'm going to start off with its asymptote lines. And its asymptote lines are going to exist here at x equals 0. And there's going to be another asymptote line here at pi, because this is the period length of tangent and cotangent. And we're also going to look at 2 pi. All right, so it's handy to have these here. All right, so now what we're going to do is we're going to put down the high, medium, and low that's associated with a positive amplitude. I'll mark that down as 2. And I like to kind of draw this swoop going up and this curve going down like that. And this will repeat again at high, medium, and low. And curve that up and curve that down. Okay, so it looks like my amplitude is going to make this a 2 and a -2 instead of a 1 and a -1. And the only thing else I have to do is now change for the vertical shift. And so I'm going to get my eraser out, and instead of having 2 and -2 and in the middle 0, I'm going to move that down 1. So this, instead of 2, is going to be a 1. Instead of this is a -2, it's going to be a -3. And our midline is now -1. So our midline is going to be y equals -1. And our vertical shift is going to be -1. Notice that these values match, but I need to have a y equals for the midline. Okay, so domain-wise, let us take a look at where we have our asymptote lines. We have our asymptote lines at x equals 0, which could literally be one of my 5 points or indicators. We have another asymptote line at x equals pi, and another asymptote line at x equals 2 pi. So it looks like I'm moving by k pi, so 0 pi, 1 pi, 2 pi, 3 pi. So my domain is going to be where x cannot be equal to k pi, and k belongs to integers. So there's a z with an extra line through it to show that z belongs to the set of all integers. Now my range is going to be all real numbers. I could use that as my set notation shortcut, or I could put the interval notation from parentheses -infinity to +infinity. My period is going to be pi, since we had no change in the period of this cotangent function, and my phase shift is going to be 0, since I had no letter c after my x inside the parentheses to indicate that this is a phase shift. So what's important about this, you'll see in this problem 6 here, you'll see that there is no parentheses here, so we have to assume that this -1 on the outside is a vertical shift. And now if instead of this I had this -1 in parentheses, then this would be a horizontal shift, not a vertical shift. So pretty important distinction when you actually start to do problems that are on your test or randomly assigned problems through the homework. You're going to have to be very cognizant of where those parentheses are. For the second of these 3 problems in this video, we're going to take a look at this problem that has not only a amplitude, but it also has a vertical shift and a period modifier. Now I did put some extra graphs on this to basically help you, in case you needed more of a final copy kind of thing. But what I'm going to do is I'm going to scroll down a little bit. I'm going to write my equation again. That way we can see everything on one screen without having to scroll back and forth. So again, your worksheet's formatted so you can see this all, but I just want to kind of get this all on the same screen. So this equation is y equals 3 secant of 1/4 x plus 1. You can see that I'm now very deliberate showing you where the parenthesis is, so this +1 is the vertical shift of 1 here. And my midline is going to be y equals 1. We usually wouldn't put a plus in front of this 1. So let us now drop in our asymptote lines. So we have an asymptote line here at pi over 2. We have another asymptote here at 3 pi over 2, 5 pi over 2, and 7 pi over 2. Now you'll see me not actually putting in those values because we have a period modifier, but we are going to be able to put in, since this is a positive 3 amplitude, we can have a 3 here, and it's moving up like so, and this is going to have a frown right here at -3. And we have another positive right here. Alright, and then finally we have a half smile here. Don't forget this little half smile, because as a requirement on the test you have to do 2 complete periods, and without putting this little half at the end here, you wouldn't have your half period. Okay, now, before we even deal with domain and range, we've got to deal with this period modifier. So the period modifier I'm going to deal with over here. The period of secant is 2 pi, and we're going to divide that by the absolute value of b. And we don't really have to worry about b values being negative, because we would actually take care of those as an odd-even function in the first place. So let's go with our 2 pi divided by b, in this case is 1/4. We're going to skip, flip, and multiply, so we skip the 2 pi, flip the 4 over 1, or so the 1/4 is 4 over 1, and multiply top times top, bottom times bottom. So this becomes 8 pi. So now what we have here is the period is now 8 pi. So we can put that here as our period length, and that would make 2 pi then, or double of this period is going to be 16 pi. And if we have to think about every single tick mark, if this is 8, then this is 6, 4, and 2. So this is x equals 2 pi. That's my first asymptote line. Then we have x equals, after that, it would be 4 pi, right? And then after, let's see, because we have 2 pi, 4 pi, oh, I'm sorry, it would be 6 pi. Okay, let me erase that. X equals 6 pi, and then we have this value here, and then we have x equals 12 pi. Or excuse me, 10 pi, shoot. Sorry about my little mental math mistakes here. So I got x equals 2 pi, x equals 6 pi, x equals 10 pi. Because here we have 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, and 16 pi. So what's going to be pretty easy is filling out our phase shift here, changing our range, because what we have is our +1 here. You'll note that the range is all real numbers, but if I change this 3 and -3, and I move it up 1 to be 4 and -2, with my midline now being 1, you can see that it doesn't actually change the range. The range still stays all real numbers. We can fill out the rest of these here. I can say 4 pi, comma -2, and I can go here to 8 pi, comma 4. So what have I been avoiding? I've been avoiding the domain. The domain is going to be tricky in this problem, because what we have here is we have x cannot be 2 pi, 6 pi, or 10 pi. So these are our danger numbers, and so what I want to do is I just want to write them out: 2 pi, 6 pi, and 10 pi. So do you notice a difference between each of these? The difference is exactly 4 pi. Okay? So if I put down my domain, and this is going to be a cool trick that you can use when you have one of these patterns that doesn't seem so obvious. See if they're being added by a constant number. And they are. They're being added by 4 pi. So if I put 4k pi, that will at least give me my spacing between each of these. And then if I just add 2 pi to it, then I have my pattern. Because if I plug a 1 in here, I get 4 plus 2, which makes 6. If I plug a 0 in here, I get 0 plus 2, which is 2. If I plug a 3 in here, I get 4 plus, sorry, if I plug a 2 in here, I get 4 times 2, which is 10. 8 plus 2, which is 10. So this is a cool pattern. And I like this pattern a lot because it can be +2 or -2 and it still works. Plug in 1. So if I plug in 1, I get 4 pi plus 4 pi minus 2 pi, which gives me 2 pi. If I plug in 2, I get 8 pi plus 2 pi, minus 2 pi, which is 6 pi. So this is the cool thing about this pattern. This pattern works for plus or minus. And I don't want to deal with any weird factoring. This will work when k is an integer. And you're going to see, whoops, I don't use that symbol. since that could mean imaginary. I know lower cases are imaginary. We're going to bust out this z with a line through it. There you go. So this is a really good thing to think about here, because you may have an asymptote line pattern that doesn't seem to fit, but it can. Just look for spacing in between the two of these. If you've ever worked with sequences in series, this might be a skill that you've used to solve those kind of problems. Alright, so I'm going to do the last problem with you here. And the last problem is going to be here, and trust me, this is going to be a little bit easier. And just like before, let me scroll a little bit further down, and I'm going to put the name of the equation right up here at the top. This is going to be y equals 4 cotangent of pi over 2 x minus 2. So we have our amplitude of 4. Our cotangent asymptote lines are here, here, and here. That is going to be at 0, pi, and 2 pi. And I'm not going to put these in here yet because what I have to do is figure out my new period. Now my amplitude is a positive 4. Looks like I'm going to be going down 2, so my vertical shift is going to be negative 2. My midline is y equals negative 2. Alright, so I'm going to have that as my change here as I finish up the problem before I get to my points. But let's also now work on this period here. Now the period, if you remember the period adjustment we made in the previous problem, it was 2 pi divided by the absolute value of b. But for tangent and cotangent, it's going to be pi divided by the absolute of b. So with pi divided by the absolute b, I'm going to go pi divided by 2. And so I'm going to then convert that to skip, flip, multiply. So I'm going to have pi over 2 over pi, or pi times 2 over pi, and that simplifies, so my period is 2. My period is 2 right here, so now I get to just write down this as a 2, which is pretty awesome. And this is going to be 1, and this is going to be 1/2, and this is going to be 3/2. And then this will be 4/2, 5/2, 6/2, which is 3, and then 7/2. And then here we have 8/2, which is 4. Alright, so now I've got all that in. I got my period made. I can put my high, medium, and low points in here. High, medium, and low. And this will curve on the upwards, and this will curve downwards. This will curve upwards, and this will curve downwards. Great. So our range is going to be all real numbers. Because if I go back and now fix my y-axis using my -2 there, instead of a 4, it's now a 2. Instead of a 0, it's now a -2, just like our midline should be. And instead of a -4, it is now a -6. The range is going to be infinitely big, so it doesn't matter that I've moved my y-axis up or down at all. So let's talk about the domain. Now the domain looks like x is equal to 0 is one of my asymptote lines, and I have x is equal to 2 as another one of my asymptote lines, and x is equal to 4 as another one of my asymptote lines. So it seems pretty straightforward that x just can't be where x cannot be any kind of k value, because here we don't have any pi values around, so x cannot be 0, 2, 4, 6, 8, 10, or negatives in this case, so -2, -4, -6. So you have to be a little bit careful here, because what you want to say is that k is even, okay? But also you have to throw in 0. And the reason why you have to throw in 0 is because by definition 0 is neither even or odd, and k could be in fact 0. Now you might have said to yourself, well geez, you never said k is odd or 0. Yeah, but because we've never landed on 0 when we were dealing with odd numbers. So that's why we have k is even or 0 when we have to literally land on 0. And now let's put in some of our other points. Let's put in 1/2, comma 2, and let's put in another one. Let's go 7/2, comma -6. So going over some of the tricky spots with this, you can see that the domain has been probably the trickiest. This was very subtle because a lot of you would probably just put down k is even, but you do have to include 0 when you actually mean to include 0. Just saying even won't cover it. And also going back to this previous problem here, you have to be very careful about this 4k pi plus 2 pi, because we can't just land on 4, 8, 12, 16. We have to actually subtract 2 from that or add 2 from that to get to the right pattern. Lucky for us, we could either add or subtract. Well, you did these problems. Probably you had no idea that the domain was going to be so tricky, but at least you got through 3 of the 4 manipulations. And in the next video, we will cover the 4th manipulation, which is going to be dealing with not only a phi, or a letter C called a phase shift, but we will also add in all the other movements, or kind of the culmination of graphing these type of graphs, which is tangent, cotangent, secant, and cosecant. Thank you for watching.